Raman spectroscopy is a technique used to study vibrational, rotational, and other low-frequency modes in a system. In this tutorial, we'll demonstrate the basics of a Raman measurement in Spectroscopy software from Ocean Optics. We'll do this by taking the Raman spectrum of ethanol in a cuvette. For tutorials on installing and using Spectroscopy, be sure to visit spectroscopytv.com. For performing this measurement, we will use a QE65000 spectrometer configured for Raman. We'll also use the Laser 785 excitation source, a fiber optic Raman probe, a sample holder, a quartz cuvette, and our Spectroscopy software. Let's begin setting up our measurement. The two connectors on the Raman probe are clearly labeled excitation and collection. Attach the connector labeled excitation to the laser. Now attach the other connector labeled collection to your spectrometer. Now slide the ferrule of the Raman probe into the base of the sample holder and lock it into place with the set screw. If the set screw is not visible, loosen the thumb screw on the top of the sample holder and slide until the set screw becomes visible. The Raman probe has a manual shutter. If the red dot is showing, the shutter is open. If it's not showing, the shutter is closed. For now, the shutter should be closed. The Raman sample holder comes with adapters to accommodate samples of differing geometries. Select the adapter for cuvettes. Loosen the thumb screw on the side of the sample holder base. Push the cuvette adapter down into the base. While still holding the adapter down, tighten the thumb screw. This attaches the adapter to the base. Add ethanol to the cuvette and insert the cuvette into the adapter. The top of the sample holder has a notch at the base that needs to be aligned with the pin on the base. The pin on the base is on the back of the sample holder. Place the top over the cuvette adapter, aligning the notch and pin. Press the top down and then twist. Once the top has been twisted, it should be locked securely into the base. Next, connect the power supply and the USB cable to your spectrometer. Once the power supply is connected, you should hear the fan for the TEC come on. Even though the probe is fixed inside the sample holder, before performing any Raman measurements, you should put on laser safety eyewear that is rated for the proper laser wavelength, in this case 785 nanometers. Plug the power cord into the laser and then turn the key on the back of the laser. On the front panel is an emergency cutoff button and a button for turning the laser on and off. Now that the setup is connected, start up Spectroscopy software. You should be greeted with the Spectroscopy interface showing a picture of your spectrometer in the Data Sources pane. By default, Spectroscopy brings up a spectrum graph when the software starts. We will use this graph after adjusting the acquisition parameters for the Raman measurement. First, we'll need to set two parameters in the software when doing Raman: the excitation wavelength and the x-axis units. To set the laser wavelength, click on Processing and then Set Laser Wavelength. Enter 785 as the selected laser wavelength. When you're done, click Accept. Now set the x-axis units by clicking Processing, then X-axis, and then Raman shifts. The x-axis on the spectrum graph should now show units of Raman shifts in wave numbers, starting at 0, which corresponds to the laser wavelength. The QE65000 has a thermoelectric cooler for regulating the temperature of the detector. To access the TEC controls, simply right-click on the picture of the spectrometer in the Data Sources frame and then select Spectrometer Features from the pop-up menu. click on the TEC tab and check the box labeled Enable Thermoelectric Control. Also check the boxes labeled Enable Periodic Update and Show in Status Bar. Now click OK to return to the main Spectra Suite window. By enabling periodic updates and showing them in the status bar, the current detector temperature is displayed in the lower left-hand corner of the main Spectra Suite window. Now let's take our Raman measurement. We can now set our acquisition parameters. Set your integration time to 3 seconds. With the manual shutter on the Raman probe closed and the shutter on the laser closed, click on the gray light bulb icon. Now that we have stored a dark or baseline, we can subtract it from our result. Click the dark subtract icon and you'll see the resulting spectrum has a mean of 0 with noise of about 3 counts RMS. Open the shutter on the laser and on the Raman probe. You should now see the Raman spectrum of ethanol after the current acquisition is updated. You can auto-zoom the y-axis by clicking the auto scale icon. If you don't see the Raman spectrum, you may need to adjust the distance between the probe tip and the sample. Loosen the thumb screw on top of the sample holder and slide the probe in or out until you achieve the desired results. If you still cannot detect the Raman signature, you may need to increase your integration time. To save the spectrum, simply click on the Save Spectrum icon. Browse to a location where you would like to save the file, give your file the desired name, and then click Save. Select the file type you wish to save. Click Save in the Spectra Suite Save Spectrum window, and then click Close. The spectrum is now saved in the directory that you specified. A handy feature in Spectra Suite for Raman analysis is the peak layer. Right-click on the spectrum graph and select Graph Layer Options. Click on the Peaks tab to display its options. Now click on the button Show Peak Baseline Layer. Check the box next to the peak in the Layer Properties frame. In the Peak Baseline Properties frame, now set the baseline to 100 counts and the peak width to 5. Check the box next to Show Baseline. Clicking OK in the Graph Layer Options window returns you to the spectrum graph. You will see that all peaks above the peak baseline we set are now automatically labeled. These easy steps should get you started with Raman measurements in Spectra Suite software by Ocean Optics. For more information, please visit us online at oceanoptics.com and tune in again next time to spectroscopytv.com. You can also contact us via email at info@oceanoptics.com.